Water table observation wells and soil moisture sensors are two methods of determining when to irrigate your crop plants. Water from an elevated water table, such as in seepage irrigation systems, can provide water to the crop plant. An observation well can be used to maintain the water table at a desired height. Observation wells are made of three parts. 1 is the well itself or a pipe buried in the ground. 2, the float, and 3, the measuring stick. The observation well is a piece of PVC pipe 1.5 to 3 inches in diameter. Holes are drilled or saw cuts are made into the pipe at the bottom of the pipe to allow water to enter the well, but a screen must be placed over the opening so that soil does not enter the pipe and fill the well. A hole slightly larger than the pipe is augured in the soil and the well is put in place. A float made of a bottle or piece of foam is attached to the end of a measuring stick made from a wooden dowel or half-inch PVC pipe. A PVC pipe with a hole large enough to allow the measuring stick to freely slide up and down is placed on top of the well to prevent rain or soil from entering the well. The observation well must be calibrated once it is installed in the field. Calibration is done by marking the stick at the top of the cap and then measuring the distance from the soil surface to the water in the well. The distance in inches is then written on the measuring stick, and marks and distances are made every inch above and below the initial mark on the stick. Using these marks on the measuring stick, the distance from the soil to the water table can be determined. Sensors that measure soil moisture use two different types of measurements and come in three types. Any of these sensors can be attached to an automated irrigation control system. The first type of soil moisture sensors measures the tension or suction that water is held to the soil. This measurement indicates the amount of energy required by a plant to take water out of the soil. Tensiometers are commonly used soil moisture tension sensors. Tensiometers are clear plastic tubes with a ceramic tip at one end and a vacuum gauge at the other. The tube is filled with water. As the water is pulled out of the ceramic tip by dry soil, the numbers on the vacuum gauge increases. Thus, the higher the number, the drier the soil. The range of readings on tensiometers for each crop can be found in the extension publications. Another device that uses soil moisture tension is called a watermark. These devices are wetted and buried in the soil. As the watermark dries out, the numbers increase. The second type of soil moisture measurement is volumetric water content. This is a direct measure of the amount of water in the soil. Two types of volumetric water sensors are available and are different in the way they measure water. The first type of volumetric moisture sensor is called capacitance sensors because they measure the electrical capacitance of the soil or the amount of current a soil can hold. These sensors can be either directly buried in the soil or read the soil through plastic access tubes buried in the soil. The second type of volumetric soil moisture sensor is time domain reflectometry, or TDR sensors. These sensors measure the amount of time required for a specific frequency of electricity to pass through the soil. The sensors must be directly buried into the soil and are made up of metal probes that pass the current through the soil between two metal probes. It takes an increasing longer time for the current to pass between the probes as the soil dries. Portable versions of these TDR sensors can be used at random places in the field as the crop plants grow. All three types of sensors can be used in vegetable or agronomic row crop production by installing the sensors prior to or at planting. Portable sensors can be used anytime during the crop season. Individual sensors should be placed at 2 depths in the crop root zone and can be placed under the root zone. The 2 sensors nearest the soil surface are used to determine if enough water is being applied during irrigation to supply water to the entire root zone. The sensor installed below the root zone can be used to determine if too much water is being applied and if irrigation amounts can be reduced, saving water and reducing the potential for removing fertilizer from the root zone.